This will come up all through this course and through college algebra, domain and range. What you should remember is that your domain is your x and your range is your y. Your domain, we can also call your input. When you put an x into the equation, you find a y value or an output. That's what we were doing on Wednesday. We said, this is the equation, this is the line of the equation. When I put 0 in for x, I get out a certain number for y, right? And then that's also a coordinate point on the graph. So we're going to define relation, domain, and range. We're going to identify functions. You're going to use the vertical line test, which is often the easiest way to decide whether or not something is a function. And then we will also see function notation. So if you have y equals 2x, function notation is just f of x equals 2x. So it is the same. Instead of y, we use f of x. That is function notation. And don't worry, we will talk about all this. I just want to warm up. And then graph a linear function, which is the same as a linear equation, which is what we did Wednesday. So nothing to worry about. A set of ordered pairs is also called a relation, kind of like the word relationship. The two numbers, the set of two xy values is related, like each point is related to the other point in that they are a line, right? The domain of the relation is the set of x coordinates. And the range of the function is the set of y coordinates. Okay, so I'm going to give you an example right now. That just means set. So in the set, I'm going to use the points 0, 5, we can use anything. -2, 2, 4, -3, and 3, -1. All right, these are a set of ordered pairs. Each of these is one ordered pair, and a set just means there's more than one. Set just means more than one. Each of these is one ordered pair. A pair is two, right? An ordered pair means there is an x followed by a y value, an x value followed by a y value. We can use those x, y values to find this point on the coordinate plane. And I made them up. It does not matter. I don't know what this would look like on the graph. This is just a relation. Okay, the domain is the set of x coordinates of your entire set. So the x here is 0, -2, 4, and 3. So if somebody asked me for the domain of this relation, I would say the domain is equal to 0, -2, 4, and 3. I would just list it in the order they listed it. I would say that the range is your y values. 5, 2, -3, -1. As you continue to see domain throughout this course and throughout future math courses, it doesn't change. When they're talking about the domain, they're always talking about your x values. Also, remember that x is your horizontal line. So if you see a graph, your domain is all of the x values of that graph, whereas range is y, and y is this the vertical line, the y-axis. Here we have our x-axis. So that is what we were talking about when we see domain and range. We're going to practice that with example 1. It says determine the domain and the range of the relation. So remember, for domain, we had x values. My domain is the set 4, -4, 2, 10. And my range is each y value. You don't need to repeat them. 9, 3, and -5 are my y values. Okay. Again, domain is your x value. It's also your input. Your range are your y values and your output. Sometimes you'll see a picture, like a function set up as a picture, where you have something going in the input. So you put in an x. I guess it's just a black box of your equation. And then out of there comes your y. So that's what they mean by input. If I input an x into the equation, I will receive out a y value. I think we said y equals 2x. If I input the number 1 into the machine, I get y equals 2, right? So I put in a 1 if f of x is equal to 2x, my output will be a 2. And remember, f of x is the same as y. So that's why we call it an input and an output, because you're more likely to choose an x as your value and find your y. It doesn't need to be a set of ordered pairs either. It can also just be a list. So this isn't even called a list. This is called a mapping, because we have a list here, and then we have mapped this input into this output. So we have drawn a line. That's the map. Input is animal, output is lifespan. You can also call your input your x always, and you can always call your output your y. Okay. What are the domain and range of the following relations? I'm going to shorten them. So this, you could just say PB, C, chimpanzee, CZ, I don't know, giraffe, gorilla, kangaroo, red fox. Did I repeat any letters? No. So those are my inputs, and then my outputs are 20, 15, 10, and 7. So if they are asking for the domain of this mapping is all the animal names. So we have polar bear, cow, chimpanzee, giraffe, gorilla, kangaroo, red fox. They might be numbers, they might be a list of names, they might be a list of types of animals. And then our range is our y values, are our y values. So we only have the numbers 20, 15, 10, and 7. And this is a good picture of a relation, because we are showing how this title shows the relationship between our input and our output, right? The input is the animal, the output is how long it lives. So it is an actual relationship that's easy to understand. Domain is all of these, range is their age. Their age at the end of life. All right, so those are relations. They are not functions. Some relations are functions. Do you remember when we talked about real numbers, integers, whole numbers, and what would be the other one? Integers, whole numbers, real numbers, and Anyway, we made little pictures of things inside other things. So all of these examples were relations. Anything that is a group that has an input and an output is a relation. Within relations, some are functions, okay? So all of these are relations. Some relations are functions. All functions are relations, not all relations are functions. A function is a relation in which each domain corresponds to only one range. Each domain has only one range, okay? When we looked at the animals, we said the polar bear has an output of 20. The chimpanzee also has an output of 20. So if I was to make that an ordered pair, the ordered pair would be P 20, where P is my X, 20 is my Y. Cow would be C 15, right? Chimpanzee would be CZ 20. Gorilla would be G 10. Or sorry, giraffe would be G10. Gorilla would be GA 20. Kangaroo would be K7. Red fox would be RF, also 7. So those would be my ordered pairs. I put each X with its Y value. Each X value can only have one Y value. So this is only a relation. This is not a function. Do you see why? Because I can't have, each of these is a unique X, right? X is P, X is C, X is CZ, X is G, X is GA, X is K, and X is RF. Each of these is a unique X value. And so each unique X value to be a function must have a unique Y value. Since P is 20 and CZ is 20, it's not a function. A function, each X value has one Y value. I'm going to make a relation. You tell me if it's a function or not, all right? -1, 3, 0, 5, and 3, -4. Is this a function? Think about your x's. Are the x's unique? We have a -1, a 0, and a 3. Those are all unique. So they each have only one Y value because they're not repeating, right? This is a function. Each X is unique. Each X value is unique. None of the X values have two separate Y values. However, if I was to give you -1, 3, 0, 5, and then instead of 3, -4, -1, -4, this is not a function. They are both relations. You can be a function and a relation. You can be not a function but still a relation. Why is it not a function? Because here we have -1 as an X value mapped to 3, and here we have -1 as an X value mapped to -4. Okay? Think about what if X is -1, Y will be 3. What kind of equation would that be? X is -1, Y becomes 3. So if we said Y is equal to -3 times x, right? And then we put in -1 for my x. That means y equals -3 times -1. So y becomes +3. If I put it in again, it becomes -4. So I put that same x value into my function and I get out a -4. That means it's not a function, okay? It's not a linear equation. Good. So a function will look something like this, where I can see a pattern. And so every time I put this x in, I will always get this y. It won't be sometimes I put this x in, I get this y. Sometimes I put this x in, I get this y. All right. Each x value is unique. This is not a function because an x value repeats with a different y value. Now they will ask for this example. Is the relation 4, 9, -4, 9, 2, 3, and 10, -5 also a function? So this is a relation because it's just a set of ordered pairs. Any set of ordered pairs is a relation, okay? Let's look at our x values. So our x values, or our domain, is 4, -4, 2, and 10. Nothing was repeating. Our y value, or our range, is 9, 9, 3, -5. There is, right? There is a repeating y value, but that's okay. You can have the y's repeat with different x's, but you can't have the same x with different y's, okay? So this is a function because no x value is paired with more than one y value. Stop me if something's not making sense. When we get to how to graph these and how to check if they're functions via graphing, that's a little bit easier. And you can always graph, okay? Don't ever hesitate to graph. So example 4 says determine whether each relation is a graph of a function, okay? So now we have the same points, right? But instead of just a list of points, we have the graph of the points. We took the points, we took each ordered pair and we put it on the graph. All right. So is this the graph of a function? Well, you need to look at their x value and their y value, and we want unique x value, right? We don't want any x's repeating with different y's. So what is the x value of this point? It's the number 3. What's the x value of this point? Also number 3. What is the x value of this point? -2. Do you see how I found that? Because it's -2 on the x-axis. This one's at 3 on the x-axis. This one's at 3 on the x-axis. Now, what are our y values? Here, my y value is 1. Here, my y value is 2. And here, my y value is -3. So, because I have the same x value with different y values, this is not a function. We have 3 when x is 3, y is 2, but sometimes when x is 3, y is -3. Not a function, just a relation. They are already relations, just is it a function? All right, let's look at these points. First, we'll look at our x values. You can plot them however you're comfortable, but I'm just going to plot starting with the x's. So from the origin, this one goes 1 on the x-axis. This one goes +3 on the x-axis. This one goes -2 on the x-axis, and this one stays at 0, okay? So if you ever have a number or a point on the y-axis, that means it went no value to the left and no value to the right on the x-axis, so it's just 0 on the x-axis, all right? We don't have any x's repeating, so we can say this is a function, okay? There's no way I'm going to see x's repeating. I don't even need to find my y's. This is a function because no x repeats. Each x is unique, but I will just finish this just for practice sake. So this is -2, +1. Our x's are always first, then our y's. This is 0, +1. It's okay if your y's repeat. This is 3, +2, and this one is 1, -3 for my y values. But this is a function. All x values are different. Not a function, x value repeats with a unique y value. Now they're giving us an equation. Is the relation y equals x squared minus 2x a function? Y equals x squared minus 2x a function. So you can make a table and try to figure it out that way. And try to see if you get out 2 different answers for any y value, any x value, right? So if I put in -1, y equals -1 squared minus 2 times -1, right? Equals, ran out of space already. -1 squared is just 1. -2 times -1 is 2, right? So now I have 3. X is -1. Y is 3. 1 squared. Yeah. Yep. All right. And then 0. Y equals 0 squared minus 2 times 0. That just gives me 0. So when x is 0, y is 0. And the number 1, y equals 1 squared minus 2 times 1 equals 1 squared is 1, -2, so -1. There is no situation where I'm putting in an x and there are 2 different y's that could come out, okay? So this is a function. When I input an x, only one y comes out. There is no way to get 0 or -1 for this equation, right? There's no way to get the number -1 and +1 for this equation. So as I test, oh, thank you. Sorry, I was missing the text. As I test it, I just want to make sure there's no way that I can get 2 different y values for one x value. Is it a function if neither the x or the y values match? Yes, it is a function if you have no repeating, right? We have -2, 0, 1, and 3, 1. Oh, that's not a good example. But yes, if there's nothing matching, like this guy, if there's nothing matching, it is a function. If you don't have any repeating x's, it will always be a function. Good question. All right, example 6, I am just going to tell you that if you have y squared, it's not a function. But let's do the graph, okay? So we have, okay, we'll just do one example. It's a long one. It's a long one, and I'm going to show you how to find the answer very quickly on Desmos, but just for the sake of math, right? So here's our xy, here's our x, here's the equation. X squared minus y squared equals 9. All right, if I put in x is 9, I'm just going to say x is 3. Nope, I'm not. I'm going to say x is 4. All right, so I have 4 squared minus y squared equals 9. Good. I'm just putting in an x, solving for y. I need to find my y. 4 squared is 16 minus y squared equals 9. Now I'm going to subtract the 16. 9 minus 16. 9 minus 16 is the same as 16 minus 9, which is 7, but the 16 was the negative, so it's going to be a negative 7. Negative y squared equals negative 7. I want it to be a positive y squared, so I'm going to divide by negative 1. And I get y squared is positive 7. Now we have not covered this, but take the square root of both sides. If I take the square root, I have to add and subtract. Put a positive and a negative in front of the square root symbol, okay? The square root of y squared makes that y plus or minus the square root of 7. Do you see how because we had to take the square root and put that positive and that negative, we have two different answers now? Sorry, okay, I will answer your question in the chat. Because we had to take that square root symbol, and the square root symbol always comes with a plus and minus, the square root symbol was to get rid of that y squared. So to get rid of the y squared, we did this square root. That square root comes with the plus and the minus, okay? So that means that my y values are x is 4, y is the square root of 7, and when x is 4, y is the negative square root of 7, okay? So when y is squared, you're not going to get a function because you get the positive value of that and the negative value of that. So when you have y squared in your equation, it's not a function. And then the question was, if it repeats, it is not a function. That's a good question. Okay, this is a good place too. Before we go to the vertical line test, I'm going to show you. So we have 0, 4, sorry. 1, 2, 3, 5. And then I'm going to write 3, 5 again. Okay? That is still a function. So if they just happen, it won't come up. But if they just happen to repeat the exact same x and y, that's okay. But if in any way the only way that this is going to be a function is if this number is a 4. If this number is not a 4, this is not a function. Okay, but 0, 4, 1, 4, 2, 4, that's a function. That one's fine. Sorry, my bracket is not fine. So you want to be looking out for your x repeating. If your x is repeating and they just wrote the entire thing twice, okay, that's weird. Hope that doesn't come up in my math lab, but that's still a function. If they wrote your x value twice and gave each situation a different y value, that's not a function. If you see that your y's are repeating, that's okay. Y's repeating is okay. That's still a function. X is repeating with the same y, that's just kind of a mistake or a trick question. So that's still a function. X is repeating with different y's, not a function. Okay. Think about what, if I just have here, I just have y equals 4. Okay. Y equals 4. When x is 0, y is still 4. When x is 1, y is still 4. When x is 2, y is still 4. That's okay. X is not even a part of it. But think about a linear equation where when I put in 0, this would have to be y equals 4 plus x, right? For this to be true. If I put in 0, I'll get 4. But that equation doesn't work for this equation, for this set of numbers. So that is not a function. That's the difference. Graphs can be used to determine if a relation is a function. A vertical line test, so remember vertical means up and down like the y-axis. If no vertical line can be drawn so that it intersects a graph more than once, the graph is the graph of a function. Oh, of course, good. I just went on before you typed that because I was worried. To intersect is to cross. So no vertical line can cross the graph more than once, it's a function. Use the vertical line test to determine whether the graphs represent graphs of functions. So our first one, sorry, they're not written very darkly, looks like that. Second one looks like that. Third one is a circle. All right, your vertical line test, think of it as just a ruler or any other straight object that you're just taking across the graph, okay? Here's my vertical line. Here's my vertical line. Here's my vertical line. Here's my vertical line. Each line can touch once or 0 times. And then this one, if your graph stopped, if it wasn't an arrow, this would touch 0 times, so that's okay. Each of these only touches once, so this is a function. And it kind of connects to the x value because here we could say our x is -10, -5. I'm making that up, right? Here it's -5, 0. Here it's 0, 3. And then here it's 3, 6, right? Each of those x's is a different x because it's a different dot I made on my graph. Do it again. Vertical line, vertical line, vertical line, vertical line. Each of those, there's one place where they cross. I know my lines are very wide because I'm using markers, but that is only one point, right? So maybe this is x is -8. Here x is -6. Here x is 0 again. Here x is 7. And in each of these, I guess y is, looks like -3. So -8, -3, -6, -3, 0, -3, 7, -3. So it's okay for the y's to be the same, but you should only have one x. Good. Here you can see, if I'm right here, right at this exact very, very, very end of my circle, it might cross at only one point right there. Sorry, not doing a very good job of drawing. So this might only have one point, but absolutely everywhere else that I intersect this circle, my vertical line will intersect at 2 places, and that is a problem. Okay, so here was my line, my vertical line test, and my vertical line intersected at 2 points. So if I think about the value of each of those points, maybe it was x is 1, y is 0 here, and then down here x is still 1, but now y is -6. So I have the same x with 2 different y's. This is not a function. But just think of taking a ruler across your graph. Anytime your ruler hits 2 different points, it's not a function. Any questions? So to me, that's the easier way, and I know I'm going super slow today, sorry. That's the easier way to decide if something's a function. So I'm going to put into Desmos the things we have seen. So we said this was a function. Y equals x squared minus 2x. We said that this is a function. So think about taking a ruler across this graph. There's only ever one place it will touch, right? Maybe it'll touch here, it'll touch here, it'll touch here, okay? We said that is a function. We said that x squared, sorry, I left that other one up, it's kind of hard to see. X squared minus y squared equals 9 is not a function. Why? Because if I were to take a vertical line test at -4 or -4.02, one of my answers would be 2.676. My other answer would be, oh no, -2.676. So I have two different y values for my x value. It does not pass the vertical line test. So that will always be just as true as the list of x and y values, okay? Don't be afraid of the vertical line test. All right, find the domain, no, yeah, is that where we are? Okay, find the domain and range. Don't love this. Okay, remember, it's just, we're just covering so much in one class. Remember we said the domain is our x values and our range is our y values, okay? Don't worry, we will cover this again, okay? Maybe just write it down. I know we don't have a ton of time left. Just write it down. If it doesn't make sense, we can go over it again, okay? There are review days in this class. These are not arrows, these are dots. These are arrows, okay? So this graph ends at the point -3 on the x, 2 on the y, right? This, unless you printed off the notes, you have no idea, right? They're tiny. 1, 2, 3, 4. X is 4, y is -4. Okay, so find the domain and the range. This is just, and write it in interval notation. So this is a lot like our greater than or less than work, okay? Domain, remember, are your x values. Keep picking up the tiny, very light. The domain are your x values. So here I have a domain of -3. Here I have a domain of 4, okay? Because those dots are colored in, they're not open hollow circles, it includes that point. So my graph goes from -3, open, or sorry, bracket, because it includes -3, all the way to 4 on my x axis, okay? My x's are my domain. And then my range, remember, are my y's. So because that's a filled in circle, I'm just going to list my y values, and remember y is up and down. But again, if this is overwhelming, that's okay. We've already done a ton today. Start at the smallest number. So it starts at -4, goes up to 2, includes -4 and 2. Okay. Is this a function? Yes, yes it is. If we took the vertical line test, there's nowhere it would cross twice. Here, because these are arrows, our domain, remember, is x. So going in this direction and this direction, my x goes on forever. So from negative infinity to positive infinity. It will never end. Those are arrows. Arrows means continues in this way forever. Good. However, y, not quite. Y is my range. My range goes positive y forever, right? So that's definitely infinity. It definitely ends with infinity. But here we had arrows going towards negative x. These are my negative x values and they go on forever. Here are my positive x values and they go on forever. Here we have positive y is going to infinity, but it does start somewhere, right? So if I count down, that's actually starting at -2. So that's just interval notation for domain and range. It's a good way to just be introduced to domain and range, but I know that it's a lot. Okay, so don't do too much. And then the rest, function notation, I think it's fun. So I'm going to save it for Monday because that's a lot. All right, we'll do function notation on Monday. Make sure you watch 3.1 if you have not watched 3.1 yet. I'm going to stop there. All right, so we are finding each function value, and we just reviewed that y equals, if it's a function, is the same as f of x equals. Y is a function of x, y depends on x, y is the dependent variable, and x is the independent variable. Good. So if f of x equals 4x minus 1, find f of 2. Just like we wrote f of x, now we can write f of 2, a function of 2, meaning everywhere you see x, you replace it with 2. So f of 2 equals 4 times 2 minus 1. 4 times 2 is 8. 8 minus 1 is 7. So f of 2 is 7. And it will give you the point 2, 7. I will show you what the graph of that looks like. So f of x equals 4x minus 1. Sorry, 4x minus 1. And I told you that you can either put y equals 4x minus 1, or you can just write 4x minus 1 if it's already set equal to y. Those are the same graph. And then we said that f of 2 is 7. That means that our x value is 2. When our x value is 2, our y value is going to be 7. That is on our line. So that is a solution. Remember, a solution just means one point on the graph and one answer to the equation. 1, 3 would be another answer to the equation. 1/4, 0, and 0, -1 would all be answers to that equation. If g of x, it does not matter if it's called f or g, you can put whatever letter you want in front of it. If g of x equals x squared minus 2x, find g of -3. That means g of -3 is, parentheses, -3 squared minus 2 times -3. Good. So a -2 times a -3 becomes a +6, right? -3 squared is -3 times -3. Remember, 2 negatives make a positive. So 3 times 3 is 9. 9 plus 6 is g of -3. So g of -3 is 15. That means the point, one of the points on this line is -3, 15. So that graph looks like it was g of x equals x squared minus 2x. Good. Even though you have on the y-axis, you have two different values of y, like 0, 0, and 2, 0, repeating y's is okay. Repeating x's is not okay. So this is still a function. And -3 on the x-axis up to 15. Sorry, I need to zoom out. -3 up to 15. Approximately that, right? I'm going to be bad at finding it. Yeah, there we go. All right, the last two examples just give different ways to answer this question. So given that g of x equals x squared minus 2x, find g negative 3, then write down the corresponding ordered pair. We actually just did this. I apologize. So the corresponding ordered pair is negative 3, 15, because we input negative 3, we got out 15. Given the graph of the following function, find each function value by inspecting the graph. So remember, we are thinking of f of x. It's never going to be f of y, okay? It could be f of x, it could be g of x, it could be h of x, but it's never going to be something of y, okay? This letter is always going to be the x value. So that means that this 5 right here is talking about 5 on the x-axis. Remember, this is the x-axis, so if we count from 0, 0 to 5, we're just going right here. Where does it cross 5? At 1, 2, 3, 4, 5, 6, maybe. 5, it's either 5, 6 or 5, 7, right? It could be this one or it could be crossing here. I feel like it's 5, 7. F of 4, 1, 2, 3, 4. This one I'm more confident about. 1, 2, 3. That would be the point 4, 3, right? Negative 5 means we go to the left of the x on the x-axis. 1, 2, 3, 4, 5. Oh, sorry, 5. And we're going to see where it crosses, negative 1. So that's negative 5, negative 1 on the y. And then negative 6 is right here. So that's all the way down. Let's see again. 1, 2, negative 6, negative 6, negative 6. Good. So we found the points on the graph. So find each function value by inspecting the graph. So just looking at the graph, f of 5 means where x is 5, y is going to be 6. There's only ever going to be one answer. Where f is 4, y is 3. Where f is negative 5, y is negative 1. And where f is x is negative 6, y is negative 6. So that's what they mean by inspecting the graph. Okay. That is the end of our lesson. And so that was 3.2. We don't need, I'm going to stop.